Well, hello there. Welcome back. My name is Ariane Murphy, and welcome back to my YouTube channel where we discuss all things skincare. If you are new here, welcome to the topic. Don't forget to hit that subscribe button so you can come back. And if you're already a subscriber, welcome back. Today we're going to dive into a topic about how to read chemical formulas in skincare. Because learning how to read a chemical formula isn't just for the chemist in a white coat. It's actually the difference in knowing if your $80 serum is worth the hype, or if you basically just bought an over-glorified glycerin and water. Now here's a challenge for you. If I handed you two completely unmarked jars, one costing $100 and the other costing $10, could you tell which is which just by flipping the labels and reading the formula? By the end of this video, you'll be able to do just that. When we talk about chemical formulas, there are a few different ways that ingredient can be shown. For example, water has a chemical formula of H2O, which is 2 atoms of hydrogen and 1 atom of oxygen. This is a molecular formula, straight chemistry. This is because skincare ingredients follow something called an INCI name, International Nomenclature Cosmetic Ingredient. Basically, it's a global system so that no matter where you buy the product, France, Korea, the US, the ingredient list will remain the same. Now here's where it can get tricky. There's a difference between molecular formula and structural formula. Take glucose for example. Its molecular formula is C6H12O6. That's a shorthand way of saying 6 carbon, 12 hydrogen, and 6 oxygen. But the structural formula actually shows how those atoms are arranged in the ring. This arrangement is what makes glucose glucose, instead of something else with the exact same atom but totally different function. This is why it matters in skincare, because sometimes you'll see two ingredients with similar names, but their structure makes them behave differently, like hyaluronic acid and sodium hyaluronate. They're part of the same family but one large polymer, and the other is a smaller short form. This small change in formula means that sodium hyaluronate can penetrate deeper into the skin. So why would it matter to skincare users like us? To put it simply, it's simply because the formula tells you the truth about what you're putting on your face and what you're really paying for. On an ingredient list, the items are listed in descending order by concentration, meaning that the first few ingredients makes up the bulk of the product. So if you see water, glycerin, or maybe dimethicone at the top, that's mostly what you're buying. Those trendy plant extracts and rare botanicals might only be sprinkled at less than 1%, but there's way more to the story to that, and that's going to be for a separate video. But generally, this is how you spot overpriced items. Over time, I compared a $100 luxury cream to a $10 one, and they usually have the same top 5 ingredients. Both of them were basically water, glycerin, and petrolatum, and the only major difference was the expensive one had fragrance, and that was the $100 upgrade. Let's keep this simple. When it comes to skincare, whether you're just starting or you've already been in the game, there are 4 main ingredient families that you'll see in your skincare formulas. First family is the humectants. These are the ingredients that pull water into the skin. Glycerin, hyaluronic acid, sodium PCA, these are all humectants. If anything says humectant, just think hydration. Then you have the emollients. These are the ingredients that smooth your skin and make it soft. Squalane and shea butter are some of the most common types. They're not about water, they're more about texture. Then you have the occlusives. These are the ingredients that lock everything in so that nothing escapes. Vaseline, dimethicone, beeswax. If you're constantly dealing with dry skin, this is your go-to. And then lastly, you have active. These ingredients do the real treatment work. Retinol, niacinamide, salicylic acid, vitamin C. These are the ingredients that target wrinkles, acne, pigment, the big issues. Let's take the CeraVe moisturizing cream for example. The first ingredient on this product is water, which is not surprising because water is a universal solvent. Next you have glycerin, and that's a humectant. It pulls water into the skin. Then you have citral alcohol. Don't panic at the word alcohol. This one's an emollient and it makes the cream feel soft. Then we have caprylic triglyceride, which is another emollient that comes from coconut oil. Then I see we have petrolatum, which is a classic occlusive. And then we know CeraVe is known to be notorious for adding ceramides, which are active that repair the skin barrier. The Ordinary 10% niacinamide serum. It has water first as the base, and then niacinamide is next in the list. This is a star active. It helps with oil control, pores, and brightening. Then we have zinc PCA. This also controls oil and has some antibacterial properties. And since the label is clearly labeled at 10% niacinamide, you can assume that anything after niacinamide is less than 10%. When it comes to reading ingredients, some people actually believe that if you can't pronounce it, then it's bad. Take tocopherol for example. Look kind of scary, but it's just vitamin E. Niacinamide, that's just a vitamin B3. Tetrahydrodecalyl is just vitamin C. Long name does not mean danger, it's just precision. And then while we're on this topic, we all know that there are some people that believe that natural is better, which isn't exactly true. I mean, poison ivy is natural, so is arsenic. Meanwhile, dimethicone, which is a lab-made silicone, is one of the most safest, most studied ingredients in skincare. Then we have the ones that believe that chemicals are toxic. Everything around you is a chemical. Water is is a chemical. Oxygen is a chemical. The word chemical does not mean poison. What matters is the dose or the amount. Even pure water can be toxic if you drink too much of it. Same rule applies in skincare. Some people believe that the higher percentage, the better the result. 10% niacinamide is strong and effective, but it isn't always better than 5%. Sometimes going up a higher dosage can cause irritation, especially if you have sensitive skin. You probably noticed that some ingredients actually look the same, but not quite. And this is where chemistry can get sneaky. But let's break it down in plain English. Take vitamin C for example. Typically, you'll see the word ascorbic acid, but sometimes you'll see this written as L-ascorbic acid. That L means that it's a version that your skin can actually use. There's also D-ascorbic acid, which has the exact same atom just flipped around, but your skin can't really do anything with it. Next is salt. This is when brands tweak an ingredient and make it more stable and penetrate easily. Hyaluronic acid is a great example. By itself, it's just a big molecule that sits on top of your skin. But when you see sodium hyaluronate, this is a salt form. It's smaller, it sinks in deeper, and it's usually more effective. Then you have these esters in skincare. Think of these as toned down versions of an ingredient. Retinol, for example, can be pretty strong. So brand created retinol palmitate, which is a gentler version. It's more stable, less irritating, but the twist, it's also weaker. It's like the baby version of retinol. And then finally we have derivative, and I've explained these plenty of time on my TikTok and YouTube. These are basically spin-off of the popular ingredient. Vitamin C is famous for this. It's like 10 derivatives of vitamin C. Magnesium ascorbiphosphate, sodium ascorbiphosphate, tetrahydrodecylascorbate, and the list goes on and on and on. These derivatives exist because L-ascorbic acid is strong, but it's very unstable. Derivatives last longer on the shelf, but they're usually not as well proven in studies. The key that I want you to memorize here is that if you see sodium palmitate or phosphate at the end, you might be looking at the salt ester or derivative. They're not bad, they're just different. This different can explain why two products that had vitamin C perform differently. So by now, you can actually flip your label and actually read it. You know the 4 main ingredient family: humectants pour water, emollients smooth, occlusives lock it in, and active do all the heavy lifting. You know how to spot when a brand is selling you a fancy version of Vaseline. You even know a little tweaks in chemistry, like salt, esters, and derivatives, and how they can totally change how an ingredient performs. And the best part is, once you start decoding formulas, skincare shopping gets so much easier. You stop buying hype and you start buying function. If you made it all the way to the end, thank you. It seriously means a lot when you're here learning skincare chemistry with me. And if you're new here, make sure you follow me on all my socials: TikTok, Instagram, YouTube, wherever you like to hang out, because I do post different skincare tips in each one. And I bet you didn't know, we now have an Amazon storefront. Click on the link in my YouTube bio and you can literally shop my routine right at the palm of your hand. I got my favorite cleanser, serum, moisturizer all in one spot for you. Again, thank you for watching. Thank you for supporting. I will definitely see you on the next one. Bye.